Hello, STT 315. This video covers Recitation 8. Task 1. A day trader buys an option on a stock that will return $100 profit if the stock goes up today and loses $200 if it goes down. If the trader thinks there is a 75% chance that the stock will go up, what is his expected value of the option? So to find the expected value, you're going to take the probability that the stock goes up and multiply that by the profit when the stock goes up. And then we'll add that to the probability that the stock goes down times the loss when the stock goes down. So we'll just plug and chug. So the probability that the stock goes up is 0.75. It says it right here. There's a 75% chance that the stock will go up. So that's 0.75. And the profit when the stock goes up is 100. It says so right here. A day trader buys an option on a stock that will return $100 profit if the stock goes up. So we'll do 0.75 times 100 plus. Now, what is the probability when the stock goes down? Now, it's not directly given in the problem, but we're given the chance or the probability that the stock will go down or the stock will go up. So in order to find this probability that the stock will go down, well, we'll take the complement of the stock going up. So that would be 1 minus 0.75. So that'll be 0.25. And then what is the loss when the stock goes down? That would be $200. It says so right here in the problem. So we're going to be doing 0.75 times 100 plus 0.25 times negative 200. And so that gives us $25. And don't forget this negative when you're doing the calculation for this negative is for the loss. And so your total answer is $25. Task 2. A gambler places one $20 bet on 3 football games and has a 50% chance of winning his bet on each game. The bookie keeps his $20. The gambler is paid later as follows, depending on the number of winners he picked. So here we have the number of winners, 0, 1, 2, and 3, and then the amount the gambler is paid. So if there's 1 winner or 0 winners, then the gambler is not paid anything. And then if there's 1 winner, the gambler doesn't get anything. 2, the gambler gets $25. 3, the gambler gets $50. So task 2, part A. What is his expected gain? Remember, a loss is a negative gain, which is just what I was saying before with the negative, and that the bookie keeps the gambler's $20. Okay, so here, the probability that x equals 0, and here x is the number of winners. So first, we're going to find the different probabilities and then the amount 1 associated with that. And so here, we're going to first look at if the probability, if x equals 0, if there's no winners. So if there's no winners, we're going to do 3 choose 0, 3 being the number of football games, and then 0 being that there are no winners. And we're given that 0.5, or there's a 50% chance of winning his bet on each game. So the success probability is 0.5. And the failure probability is 1 minus the success probability. So that's 1 minus 0.5, which is also 0.5. And this is following a binomial distribution. So here, this is going to be 0.5 to the 0 to indicate this is with the success probability. So there's no successes in this situation, but this would be 3 failures. So that's why the 3 exponent is over the failure probability, which is 1.5. So when you solve this, you get 0.125. Now, what about the probability that x equals 1? So now we're in this situation here. So the probability that x equals 1, and that would be that there's 3 football games, and then 1, choose 1. And here the success probability is 0.5, but this would be that you would get 1 winner. And then 1 minus 0.5, this is the failure probability, there would be 2 here. And so also a little tip is that these numbers should add up to 3, the exponent numbers. And anyway, so when you simplify that, you get 0.375. And then what about when there's 2, when x equals 2? So that'll be 3 choose 2. So the success probability is 0.5 to the power of 2. And then 1 minus 0.5, this is the failure probability. And then 1 of the 3 is failure. So then that equals 0.375. And then last but not least, if the number of winners is 3, so that would be 3 choose 3 times 0.5, the success probability. This will be 3, and then this is the failure probability, so 0.5 times 0, or not 0, to the 0 exponent, and then equals 0.125. All right, so we can then, we can start filling in this table where we have the number of winners, the probability that x, the number of winners, equals xi. So here for this first cell of this column, probability of x equals, in this case, xi equals 0. So probability of x equals 0 is 0.125. And I'm just going to fill in the information we just solved, which is the probability that x equals 1 is 0.375. That was right here. Probability that x equals 2 is 0.375. That was solved here. And then the probability that x equals 3 is 0.125, which was solved here. And then we also need to know, okay, what's the amount 1 associated with these values? So then we can calculate the expectation or the expected gain. So here we were given that the amount the gambler paid is 0 for if x equals 0. But remember that the bookie keeps his $20. So here we would do 0 minus 20, and that would give us negative 20. What about in this situation here, where the number of winners is 1? The gambler is paid nothing again, but the bookie keeps his $20. So 0 minus 20 gives us negative 20. So the gambler's out $20. Okay, what about when the number of winners is 2? So here, the gambler is paid $25, but in order to have him play or whatever, he had to give the bookie $20, right? So we're going to do 25 minus 5, and that's going to give us $5. So that would be like his net gain. And then what about if there's 3 winners? So if there's 3 winners, the gambler gets $50, but he had to pay $20 to gamble. So 50 minus 20 gives us 30. So this is the amount 1 for each of these scenarios. So now we're set up well to be able to calculate the expected gain. So the expectation of x equals the negative, we're going to take this value, the amount 1, and multiply it by that probability, the associated probability. So we're going to do negative 20 times 0.125 plus negative 20 times 0.375 plus 5 times 0.375 plus 30 times 1.25, and that equals negative 4.375. So that is our answer. That is the expected gain. Task 2B. What is the standard deviation of his gain? So here we're going to first solve the variance, and then we'll take the square root of the variance to get the standard deviation. So what is the variation? So that's going to be the sum of xi, the sum over I from 0 to 3, and we're going to take xi minus the expectation, which we just found, the expected gain squared, times the probability that xi equals x. So here, for for when I equals 0, our xi is going to be negative 20 minus the expectation of x. So the expectation of x we found was right here, 4.375. So 4.375 squared times the probability that xi equals x. So that is 0.125. And then we're going to add that to negative 20. That's the amount 1 for when I equals 2, or I equals 1, sorry, when I equals 1. And then we're going to subtract the expectation of x, which was 4.375 squared times the probability that xi equals 1, which is 0.375, which is found right here in this table, plus 5, right here, 5 minus negative 4.375 squared times the probability that x equals, that x equals 2. So that's 0.375. So that's written here. And then plus 30 minus negative 4.375 squared times 0.125. So when you simplify all of this, you get 302.734375. And then to find the standard deviation, you will take the square root of that and get 17.39926. So when you round, you get 17.40. So $17.40 is the standard deviation of his gain. A fair die is tossed 9,600 times. Find the expected number of times, expectation of x, and the standard deviation of x, that the phase 2 occurs. So when a fair die is tossed, each face has an equal probability of appearing. So the probability of getting a specific face, such as phase 2, on a single toss is 1.6, because there are 6 sides on a die. So the probability of getting a specific face, so for example, face 2, or like 2 dots on a die, is 1/6. 1 over the total number of possibilities, which there's a total number of possibilities of 6. So, and we're going to have x be the number of times phase 2 occurs in 9,600 tosses of the die. So in order to find the expectation, we can multiply n by p, where n is the number of trials and p is the probability of success on a single trial. So n in this case is 9,600. And the probability of success on a single trial is 1/6. And that's because we're interested in when phase 2 occurs, the number of times phase 2 occurs. So that's going to be 1/6 is that probability of success. So then the expectation of x, so we're just going to do n times p, is going to be 9,600 times 1/6. Which gives us 1,600. And then the standard deviation is going to be the square root of n times p, the success probability, times 1 minus p, or the probability of failure. So the square root of 9,600 times 1/6, that's the success probability. And then the probability of failure is 1 minus the success probability, which is 1/6. So when you do 1 minus 1/6, you get 5/6. So when you simplify, you get 36.51. So 1,600 is the expectation of x, and 36.51 is the standard deviation of x. And the last task is to choose which of the choices is most likely to have a binomial model. So let's look at A, the number of black cards in a 10-card hand. So this does not follow a binomial model because there is not a fixed number of trials. In order for there to be a binomial model, there has to be a fixed number of trials. So A is out. Then B, the colors of cars in Wegmans parking lot. So in this situation, there's more than 2 possible outcomes for each car because colors can vary. You can have black, you can have white, you can have green, you can have red, you can have blue. So this is not a binomial model because you would need only two possible outcomes for binomial. So B is not a match. C, the number of hits a baseball player gets in 6 times at bat. So this does follow a binomial model because each at bat is independent and there's 2 possible outcomes. There's a success, which is if you were to hit the ball, or a failure, which means there's no hit. And there's a fixed number of trials as well, because we have 6 times. Okay, what about D? So the number of cards drawn from a deck until we find all 4 aces. So this does not have a fixed number of trials because the number of cards drawn is not predetermined. So we don't know, and we're not given how many tries we should draw cards. We're just drawing until we get all 4 aces. So this is not a binomial. There's not a fixed number of trials. And then lastly, part E, or option E, the number of people we survey until we find someone who owns an iPod. So this also does not have a fixed number of trials because we could survey 2 people, or we could end up surveying 150 people. There's not a fixed number of trials. So that does not follow binomial. So the only option for following a binomial model is C. And if you notice, the previous tasks that we covered also are binomials, where there's 2 options. There's a fixed 2 options, meaning 2 possible outcomes. There's independent trials and a fixed number of trials. And this concludes this recitation, and I hope this was helpful. Bye.